This is Geometry B, Unit 6, Surface Area and Volume, Lesson 1, Space, Figures, and Cross Sections. So we're getting out of two-dimensional geometry and getting into three-dimensional geometry. And yes, my cat is decided she wants to be part of this video. So anyway, the simplest geometric solid to draw is a cube. So let me sketch a cube here. I'm going to do what's called a wireframe drawing, okay, in which we draw the edges and we show any hidden edges as well. But hidden edges are dotted, okay, and so we have a cube, so to speak, right? And it has vertices. Vertex, singular. Vertices, plural. Okay, another word for vertices are corners. Okay, the cube has 1, 2, 3, 4 vertices on top, 1, 2, 3, 4 vertices on top, on bottom. So the cube has 8 vertices. Okay, and then we have edges. Edges are sides, and there are 4 on top. 1, 2, 3, 4. Let's change colors here. So there are 1, 2, 3, 4. And then 5, 6, 7, 8. And then the verticals, 9, 10, 11, 12. So edges, there are 12 edges, okay? And then there are faces. There's a front, there's a back, there's a right, there's a left, there's a top, there's a bottom, front, back, right, left, top, bottom. There are 6 faces. Okay, and that brings up something called Euler's formula. It looks like Euler, but it's pronounced Euler. Euler's formula. If you take the two smaller values, 8 plus 6, it doesn't equal 12. You might think it does, but it equals 12 plus 2. 8 was the number of vertices. 6 was the number of faces. 12 was the number of edges. And so this is Euler's formula in general. Vertices, that's corners, plus faces, that's flat surfaces, equals edges plus 2. Okay? And you can use this to answer various questions. For example, what if a polyhedron has 9 vertices and 6 faces? How many edges does it have? Well, 9 vertices plus 6 faces equals edges plus 2. 9 plus 6 is 15. Edges plus 2, subtract 2. It should have 13 edges. Okay, that is if such a solid actually even exists. Okay, but this is a formula that applies to all polyhedra, all solids, right? And so there are names for this. This one has 6 faces, so we call it a hexahedron. Hexa for 6, hedron. There's octahedron, which have 8 sides. There's dodecahedron, which have 12 sides. Icosahedrons have 20 sides, right? So hedron is faces, as opposed to polygons, which are edges on two-dimensional shapes. Now we can also talk about slicing. If you've ever played the old Wii game Fruit Ninja, right, where you toss fruit in the air and you slice it. we talk about the faces that are the faces of what is sliced. So let me draw a cube again, and we'll finish with this here. So let me draw a cube. Okay. And there are a number of ways I can slice this cube. Okay, let me copy it. Gonna make a few here. Okay. And I can slice it along any 3 points here. Let's say I slice it through these 3 points. Okay. Then I would create a triangular face. So by slicing, I can create a triangle from a cube. Okay. I can create, let's see, let's try this one here. Actually, let's do this here. If I slice it diagonally, like this, that creates a rectangle. Rectangular face. If I slice it this way, well, let's see. I'm trying to think of how I can slice it here. And what if I just slice it straight down the middle? What shape would be made? That would be a square. Okay. If I slice it at an angle, like so, it's hard to see, but there's 1, 2, 3, 4, 5 sides. Pentagon. Okay, so you can slice it a number of ways and come up with all kinds of faces, shapes of faces from a single solid. All right, so hopefully that helps. Remember the words vertex, face, edge, and cross-sectional shape.